Okay, we are doing lesson 30-1. That is on page 411 of your Springboard book. Okay, the very first thing that you need to know is rate of change is the exact same thing as slope. Okay, today we are going to model linear relationships using functions, identify and represent linear functions with tables, graphs, and equations. All right, the rate of change in a relationship represents the ratio of the vertical change in y, which is same as output, to the horizontal change in x, which is input. So again, it's just saying rate of change is slope, which means you're going to have your up and down change over your over change. Okay? All right, let's look at our problem. The height of water in a pool is shown below. The height of water in a pool is shown in the graph below. Okay, height of water in a pool, and we're going to look at our axes here. It's got your height in inches on one side, time in minutes. Okay, determine the rate of change of the height of water in the pool. So again, rate of change is just the same thing as slope. Okay, so first we are going to pick 2 points. We want to pick ones that are on intersections. So this is a good one. That's a bad one because it's not in the middle here. Okay, this is another good one because it's on a crisscross. All right, I'm going to erase this so it's a little more clear. And you can pick any of these points. I'm going to circle all your options. Okay, that would work. This one work. You could pick any 2 of these 4 points and you're going to get the same answer. All right, so I'm just going to do this one since it's right here. I'm going to make my little triangle. Okay, we got to look at our label, all right, before we count because sometimes they try to mess you up on the label. This one goes by ones, so I'm going to literally just count by ones. 1, 2, 3, 4, 5. So I'm going to write 5 there. All right, now I'm going to count the top. Okay, the most important thing you need to know about this lesson, lesson 30-1, is that rate of change is the exact same thing as slope. Okay? So, our learning targets. We're going to model linear relationships between quantities using functions. Then we're going to identify and represent linear functions with tables, graphs, and equations. All right. The rate of change in a relationship represents the ratio of the vertical change in y to the horizontal change in x. So if we drew that, we would put our little fraction bar. Okay, on top, this fraction bar, that's where we get the ratio. Okay, so that's where that word comes in. So ratio. And on top, we're going to put our vertical. Okay, so there's our vertical part of our definition. Okay, then on bottom, we're going to put the horizontal. Okay, so it's a ratio of vertical to horizontal change. Okay, then it's got this math term over here for you to look at. If you want to look at that for help, you can. I'm going to just keep going. Okay, the height of water in a pool is shown in the graph below. There it is. Determine the rate of change. So for marking up our text here, determine the rate of change of the height of water in a pool. Okay, when we pick points for our rate of change, we always want to pick 2. And again, rate of change is the same as slope. And the 2 that we want to pick are going to be on this little crisscross. Okay, any of the crisscrosses. We don't want one in the middle. So what I mean by that is this right here, it's not in the middle of a crisscross. It's just randomly floating. Same with this one. I'm going to circle some points that you could use. Now remember, you only have to pick 2, but here are our options. That one's good. That one's good. That one's good. That one. And then most people forget about 0, 0. If it's on that 0, 0, it works. Okay, so any of those you could pick and get the same answer. I'm just going to do the one in the middle. Next, I'm going to draw my little triangle like you see over here. Okay, then I'm just going to count. So I look at my label here and I notice I go up by 1. So when I count, I'm going to go up by 1s. 1, 2, 3, 4, 5. So that has a vertical change of 5. Now if I look at my scale here, I actually don't go up by 1s each time. I go up by a half, and then I get another 1 to get the 3. So this whole thing is a 1. So when I go up here and count it, I've got a whole 1 here, and then there's my 2. Now I'm going to plug it in so it's a ratio. So a ratio of vertical over horizontal. I'm going to put the vertical, the 5 on top, and the 2 on bottom. Okay, so this is way number 1 to find the rate of change. Way number 2 means you would actually use your points. So I'll put that in a different color. My point here is 2, 5. Okay, so we look here, there's our 2, there's our 5. My point up here is going to be 4, 10. Okay, my vertical change is always my second number, so this 10, the 10 and the 5. My horizontal change is always this first number, so 4 minus 2. And then if we do it right, we should get the same answer. 10 minus 5 is 5, 4 minus 2 is 2, and there we go, same answer. So both these ways work. You can do whichever one is good for you, okay? And you could have also picked any point. Usually when I have 0, 0, I try to pick that because it's easier to subtract. Because if I had done 0 and this guy, I would have done 5 minus 0, which is 5, and 2 minus 0, which is 2. So you can be really flexible about whatever you change. But if you notice, we always have the same answer. So right here, we count up, we still have 5 over 2. If I had done this one, I still have 1, 2, 3, 4, 5 over 2. If I had done this one, I still would have gotten 5 over 2. So it doesn't matter what points you pick on the line, you're always going to get the same answer. If we had done something crazy, like, I'll do it in a completely different color and you don't have to write this down, but if I had picked this one and this one, okay, I would have gotten 4 over 10, and we know that 10 over 4, we can divide the top and bottom by 2, and we're still going to get 5 over 2. So it doesn't matter what points you pick because it's always going to end up being 5 over 2, no matter what, for this equation. All right, we're going to write this in a nice sentence when we're answering it. So we're going to write the rate of change is 5 over 2. It just says describe the rate of change in the graph. Okay, this is where it wants us to get our labels in. So we're going to say the water goes up 5 inches, because it says inches over here, 5 inches every 2 minutes. And we know it's 5 inches every 2 minutes because the 5 represents our vertical, and that's in inches, and the 2 represents our time. Okay. All right, example A. Let's see if I can make that a little smaller. Okay. The table shows the data from the graph above. How is the rate of change from the graph above represented in this table? Okay, and then it goes by and it answers it. It says, look at the change in time between the consecutive minutes. So, real quick, let's turn 5 over 2 into a decimal, because if we notice, we've got decimals going on here. So it's going to be helpful if we can see that. All right, so if we pick 2 points, let's say I pick 0 and 1. Actually, we'll do something else. We'll do 0, this guy, and this guy. You notice here, this goes up 2, and this goes up 5. Now if we pick this one, again, it's going to go up 2, and it's going to go up 5. Again, we're going to go up 2, and we're going to go up 5. So we can see our pattern there. All right. So it's saying look at the change, and then write the ratio as a change. Write the ratio of the vertical change to the horizontal change. So because they went ahead and did 5 divided by 2 and got 2.5, they know that any number is over 1. So they changed 5 over 2 to 2.5 over 1. That's kind of confusing. You won't really have to do that. This is a weird example. But the basic thing you're looking here is to see that there's a consistent pattern. And then they gave you like this perfect, awesome answer that we would write if we were like robots. Okay, now we're going to try our own. The table below represents the fare schedule for a taxi cab driver's fare. Determine the rate of change. So again, rate of change equals slope. They didn't give us a graph this time, so we can't count. We're going to have to pick 2 points and subtract. Or, actually, we can look right here. In our 5 and our 8, the difference there is 3. Okay? Over here, 0 and 1 is 1. You can always assume that this first number is your x and the second number is your y. If we remember, x is horizontal, y is vertical. Okay? We look here. 1 to 2 is going to be 1. 2 to 3 is going to be 1. 3 to 4 is going to be 1. And 4 to 5 is going to be 1. We look over here. 8 to 11 is 3. 11 to 14 is a difference of 3. 17 minus 14 is 3. And 20 minus 17 is 3. So this side's always going up by 3. This side's always going up by 1. We know our rate of change, which I'm going to abbreviate to ROC, is your vertical change over your horizontal change. Okay, our vertical change is 3. Our horizontal change is 1. And 3 over 1 just simplifies to 3. So if we're answering this question, we're going to write the rate of change is 3. For letter B, it wants us to interpret the meaning, so all we're going to do is put these labels in here. So, the rate of change is 3, okay, and the 3 represents the cab fee, so $3 per, okay, the per represents our little fraction bar there, per, and then mile. Okay. All right. There's our try these A. Moving along. Go ahead and try to check your understanding on your own really quick. Okay. The rate of change here, if we put our slope-intercept form, the rate is always m because the rate of change is the same as the slope. Okay, our m is 20. Letter B, we notice 15 to 18 is 3. 0 to 1 is 1. Okay, let's check for a pattern. 18 to 21 is 3 again. 21 to 24 is 3. 24 to 27 is 3. And 27 to 30 is 3. Then we can look over here, see they're going up by ones. Our cost is always going to be our vertical. Our number of days is always our horizontal. Okay, pretty much assume that your first number is always x. So 3 over 1, which is the same as 3. Over here, we're going to do our little triangle. Remember, we're going to pick nice points that are on an intersection, traveling on my line till I find one. Here's one. Okay, I went up. Ooh, we're going by 2's here, so go up 2, 4, 6, 8, 10, 12, 15. And then over here, I have to go all the way over to here before I get to 1. So that's 1, 2. So my slope is 15 over 2. and that simplifies to 7.5. Both of those answers are correct. Okay. So data points are linear if they show a constant rate of change. When you plot the points of the linear data on a coordinate plane, they lie on a straight line. The data point represents an item 1 and in example A are linear. Jamila is using a straw to drink water from a cylindrical cup. So by the way, a cylindrical cup just means a cup, just like a normal one. I don't know why they put cylindrical on there. Okay, so like a little cup. That's a mug, but still works. The height of the water remaining in the cup is a function of the time the person has been drinking. The following graph gives the height of the water at different time intervals. All right, so it wants us to use the data from the graph to complete the table. So all we're doing here is we're looking up the points. They gave us the x value. We just have to find the y value. All right, so let's look at that. Here's our 0. So if I look on my 0, I'm going to go up and see there's my dot at 15. On 10, and it says time, and time's down here. That's how I know to go with this 10 instead of this one. Okay, so I start at 10, I go up. It's between 12 and 13, so I'm going to put 12.5, because 0.5 is telling me in between. Next, it wants me to do 20. I go up, and I see that's at 10. Then 30, I go up and see that's between 8 and 7, so I'm going to do 7.5. For 40, I'm going to go up, and I see that that is at 5. Okay, and then for my last one, I can't see it, so give me a second so I can look at my actual book. I bet you can do this without me. But you can beat me to it, actually. Okay, my last one is 2.5 because that's between 3 and 2. All right. I think that's everything on this page. Yep. Describe any patterns you observe in the table about the height of the water over time. All right, let's go back to this table. If we look at it, we see that we're going up by 10 seconds each time. Okay, and then on this side, 15 minus 2.5, that's going to give me 3.5, I believe. Oh, nope, I'm wrong. It's going to give me 2.5. So if I do 15 minus 12.5, I get 2.5. If I do 12.5 minus 10, I get 2.5. If I do 10 minus 7.5, I get 2.5. If I do 7.5 minus 5, I get 2.5. And if I do 5 minus 2.5, I get 2.5. Okay? So I notice that my height goes down 2.5. And what was my label on that? 2.5 centimeters per minute, per second. Oh no, I was so wrong. Per 10 seconds, that was my pattern. It's hard flipping back and forth. Per 10 seconds. Is this relationship between time and height of the water linear? Okay, it is linear. If we look at the graph, it is linear because it looks like you could connect the dots to make a line. So that's literally what it means. You don't need to overthink that. It's linear because it looks like you can connect the dots. Explain using the table. So we know it's linear because each side has a pattern, has a constant, or not constant, we're going to use a big word, consistent pattern. And all that means is the left side always goes up by 10 and the right side always goes down by 2.5. Okay? What is the change in water level from 20 seconds to 30 seconds? So at 20 seconds in our table, it said that we were at 10. On 30 seconds, it said 7.5. 10 minus 7.5 is going to be 2.5. So we're going to put 2.5. Determine the change of the water level over time. So we have already done this, actually. When we did that pattern on our table, we noticed that the height went down by 2.5 and that happened every 10 seconds. Okay, so that's our horizontal one. Now, because it went down, it's actually going to be a negative 2.5 over 10. Now, we do not like combining decimals with fractions, so we're going to actually simplify this. Negative 2.5 divided by 10 is going to give you negative 0.25. Okay. Predict the height of the water at 52 seconds. Okay, so we know, if we look at our table, it said that time was on the left and height was on the right. Okay, usually the left is your x value and the height is your y value. And we can confirm that by looking at our table, because if you look at the table, the water height is on the y-axis and the time is on the x-axis. So we're just going to write y equals height and x equals time. Now we're going to have to make our equation. So our equation is going to start out with mx plus b equals y. Our b is always our starting value. If you look at our table, the starting value is 15 because it's 0, 15. Okay, if we look at our slope, we already wrote that up there, it's negative 0.25 x. A equals y. We are trying to find the height at 52 seconds. So we're going to plug in 52 for our x because we said that was our time. So negative 0.25 times 52 plus 15 equals y. Okay, now if you plug that into your calculator and solve it, you're going to end up getting you're going to end up getting 60 seconds, I believe. No, I completely lied. You're going to get about 2. You're going to get 2 point something. Okay? So I'm going to let you finish that one because Miss Peacock doesn't have a calculator on her right now. All right, it wants us to write a function that gives us the height of the water using h and t. Now, we already wrote a function, so we're just going to put in the variables they said. We said height was y, so I'm going to put an h there where the y is. Then it said that they want us to use t for time, so I'm going to put a t where the x is. All right, so there we go. That's our function. How long will it take Jamila to drink all the water and completely empty her cup? All right, if her cup is empty, she's going to have nothing in it, okay? What number represents nothing? Right, it's 0, okay? So 0 is going to be our height if we have nothing. All right, and since our height is right here, we're going to plug that into our equation and we're going to solve. Okay? So, first I'm going to subtract 15 from both sides. Then I'm going to divide by negative 0.25, and we should all know how to solve an equation by now. If not, you need to practice that more on IXL. Okay? When we solve that, we're going to end up with 60 seconds. So t equals 60, or 60 seconds. Okay. So go ahead and try the check your understanding. All right. I'm going to put the answers up. So whenever you're ready to check your answers, then push the button. All right, number 12, it wants us to graph. So we're going to put a dot at 0. Then we're going to put a dot at 500, which is going to be in between 0 and 1,000. Then we're going to do 40 and 1,000. 60 and 1,500. 80 and 2,000. 100 and 2,500. 120 and 3,000. 140 and 3,500. About there. And then 160 and 4,000. Then we're going to connect those dots, giving us a nice line. We can see that this is linear because we had our line there. It wants to know what is the rate of change. The rate of change is going to be 500 bushels. That's our label. Every 20 minutes. Okay. It is linear because it has a slope. Okay, write a function for the situation. So our b is our starting value. It starts at 0. Our m is our slope, which is 500 over 20 equals y. We can actually simplify 500 over 20. We can simplify that to 25. So if we do 500 divided by 20 in our calculator, we're going to get 25. X equals y. Both of these are right. The silo holds 7,000 bushels. How many hours will it take? So we're going to plug that into our equation. I'm going to use the 25x one because it is just easier to work with than 500 over 20. So our x, if we look here, is time in minutes. Our bushels is going to be that y. It's telling me how many bushels, so I'm going to put that in my y spot. And then we just solve by dividing both sides by 75, and that's going to give me x equals 280 minutes. If you have any questions on that, make sure to raise your hand. Oh, I hit a weird button. Okay, we're going to skip that. You need to make sure you take the x ticket, okay? Because I am grading it. All right.